Two drunken college students have filled an empty bear keg with rocks and tied ropes to it in order to drag it down the street in the middle of the night. The stronger of the two students pulls with a force of 100 pounds at a heading of north 75 degrees east, and the other pulls at a heading of south 68 degrees east. Didn't put the questions, but the questions are, what force must the second student pull so that the keg moves due east, and then what is the magnitude of the resultant force? So let's draw a picture so we can see what's going on. So the first student pulls north 75 degrees east, so this is 75 here, and the magnitude is 100. Okay, the second student pulls from south 68 degrees east, and so this is 68 here, and we don't know, they'll call this force 2, and we don't know what that is. And that's one of the things we're supposed to find. And we want the resultant vector to go due east. We'll call that F3. Okay, so let's go ahead and express vectors in component form. So force 1 is going to be 100 cosine of the angle of that vector, and it's 75 off from north, but we want to express these vectors in component form measured off from 0, so that would be this, which would be 15 degrees, because we just do 90 minus the 75. So this is going to be 15 degrees, and the second component is going to be 100 sine of 15 degrees. All right, let's go ahead and work on F2. And so we don't know its magnitude. That's what we need to find. And we'd have cosine of, let's figure out this one's angle. So this would be measured around like this. So that's going to be 270 around to there plus the 68. So that's going to be 338. So cosine 338, and then whatever the magnitude of this one is, and sine of 338. Okay, and then if we want to figure out when we add together, what we've got is if we add F1 plus F2, that will give us F3, which will be the direction that the keg moves. And one of the requirements then for F3 is we want it to be due east. So we're going to say the magnitude of F3 and then cosine of, if we want this to go due east, that's just going to be 0. And then magnitude F3 sine of 0. All right, so we know that if we add F1 plus F2, it needs to equal F3, so we're just going to do this component-wise. Let's take the first components, and then we will take the second components. And so first components, we'd have 100 cosine 15 plus magnitude F2 cosine, cosine of 338 equals magnitude of F3, because the cosine of 0 is 1. Okay, let's go ahead and write our second components. We've got 100 sine of 15 plus the magnitude of F2 sine of 338, and that needs to equal 0 because it needs to equal this second component, and sine of 0 is 0. So we can take the second equation and solve it for the magnitude of F2, and that's the first thing we're supposed to answer. I'm going to erase over here so that I've got room to write down that calculation. So if we solved for magnitude of F2, that would be, we've got 100 sine 15 we could move over, so negative 100 sine of 15 divided by sine of 338. Okay, so we can put that in the calculator, and that'll give us the magnitude of F2. And it looks like when I do that, I get, it tells us in the problem to round to the nearest pound, we get 69 pounds. So student 2 needs to apply 69 pounds of force so that the keg will move due east. Now we can put the 69 in our first equation we had right here. We can put 69 right there, and then we can just compute 100 cosine 15 degrees plus 69 cosine 338, and that will give us the magnitude of the resultant force, and that's the last thing we needed to find. So the magnitude of the resultant force looks like to the nearest pound is 161 pounds.